Hey folks! So at the end of class period on Wednesday, I asked you guys to try and work on problems 3 and 4 and get as far as you could. And the reason is because it kind of prepares you for today's video. What we're going to be doing today is we're going to be looking at problems 3 and 4. And I recognize these problems are very challenging. Believe me, I do. But trust me, this is such an incredibly valuable skill, and we're going to spend a lot of time working on these types of problems. In fact, if you can do these problems that I'm giving to you now and you take physics in college, you're going to be so much more prepared. And quite frankly, you're going to improve your math skills so much more later in life because what physics does is it shows you how to take the math you learn in math class and actually use it. All right, let's get into it. So I always encourage you guys to draw a picture whenever you're working on these problems. I think drawing a picture is really useful. So we've got a cart. Check it out. We've got some wheels. We've got our body. Nice. It's a great cart. And it's currently being pushed by a fan. It's being pushed by a fan to the right. Okay, so we can give ourselves a nice little arrow. There we go. And it tells us in the problem that it has an initial velocity of 5 meters per second. So we can jot that down. Our initial velocity is 5 meters per second. There we go. And we also know that it travels a total of 12.5 meters. Okay. Cool. And basically what happens is at the point eventually that this car stops moving and begins moving backwards. Okay, I misspoke a little bit there. At 12.5 meters, what happens is the car stops moving and it starts moving backwards. So that honestly is where this problem is just a little bit trickier than some of the others have been. The key in this line is that the cart stops moving. So if the cart stops moving, what does that mean the final velocity is? It's 0. Cool. So what we need to do is we need to figure out the acceleration. Right now, the acceleration is kind of a question mark. That may or may not come through. We'll see. How did that look? Yeah, no, it did not. There we go. Acceleration equals a question mark. Okay. So what we've done so far is we've identified what we know in this problem and what we're trying to find in this problem. And that's half the battle right there. The next thing that we need to do is we need to identify what formula are we going to use. So here, go ahead, take a quick look. Let me make it so that we can actually see all of this at the same time. There we go. These are the 4 kinematic equations that we've learned so far. Which one is going to be the most useful in this particular scenario? Yeah, good. You'll notice we've got the initial velocity, the final velocity, the distance, and we're trying to find the acceleration. And all 4 of those variables are in our 4th equation. So let's write it down. Vf squared equals Vi squared plus 2ax. Okay. There's 2 ways we could go about doing this problem. We could try and just substitute the numbers in and then do our math, or we could try and do our math and substitute. For this particular problem, I'm going to substitute my numbers in. I think it's just going to be a little bit easier. I saw a lot of you guys doing that in class today, and so I'll just mimic what you were doing. So we've got 0 meters per second squared. That's kind of nice. It's just 0, right? 0 meters per second squared is just ultimately going to be 0. VI squared is 5.0 meters per second. And that is all going to be squared, not just the number, but the units as well. And we've got our acceleration, which we don't really know, multiplied by 2. So there we go. We can get our little draw tool back. Come on, please write. I hate it when it does that. Painful. Okay, there we go. Plus 2ax. And we know that our distance is 12.5 meters. Okay. Cool. So we can do a little bit of math. We can take 5 times 5 is just 25, so 0 equals 25 meters squared. Because remember, we have to square our units. That's a meters squared. There we go. Meters squared per second squared. We've got to square our units in addition to squaring the numbers themselves. Plus 2a times 12.5 meters would be 25 meters times a. Great. All right, and we're almost there. We can subtract 25 from both sides. So we would have negative 25 meters squared per second squared equals 25 meters times a. And we'll divide both sides of this equation by 25 meters. By 25 meters. And that's going to cause this to cancel out. That'll cancel out with this, as do the units. And our 25 here is going to cancel out this 25 and the squared on our meters. And we will be left with our acceleration equaling 25 meters per second squared. Oh gosh, lordy, no, not 25, sorry. That is very wrong. It's going to equal 1, sorry, I'm not thinking straight. 1, because 25 divided by 25, 1 meter per second squared. More specifically, negative 1 meters per second squared. There we go. Cool. So these are really challenging problems. It's challenging for a lot of different reasons. One, you have to figure out which formula we're going to use. You have to set up the problem. You have to do the math. But this is what actual scientists do in the real world, is we do math like this. Engineers are constantly having to use equations to solve for things. And in fact, you use equations in your day-to-day life, you just don't even recognize you're doing it. Cool. We'll talk more about number 4 either in another video or in class next week. But bye for now.